So what I wanted to cover is we talked a little bit about stars and their magnitudes and their colors and so forth, but we didn't talk about some of the different kinds of stars that can be fun to observe. And one is and let me blow this up so that we actually have the slideshow view. One are double stars, and you think I could have found a better picture than this. I think I'll look again and see if I can't come up with something better. But most stars, in fact, have companion. They're multi-star systems, and they orbit a common center of gravity between them. Our sun is unusual in being all by itself like it is. And then you also have some stars are triplets and quadruplets, and you got a pair orbiting a pair and so forth. And some of these are far enough apart or close enough to us, or the combination thereof, that you can split them with a pair of binoculars or a small telescope. And what's fun about them, in particular, for just the casual observer, is that when you've got a pair of when you split a star into its component parts, a lot of times you can see color that you can't see otherwise. And there's something about them being close together like that. Suddenly the brain is able to tease out the colors. And this is Alberio, which is a nice, beautiful double at the beak of Cygnus the Swan. It's the beak star in Cygnus the Swan. And with a pair of binoculars or a small telescope, you probably could split it. And when you do, one of them has a sort of a bluish tint to it, and the other one's sort of a gold tint to it. And so it's really attractive object. And then, of course, these double stars have a rich scientific foundation. You know, they build these particle accelerators, you know, to study and explore the physics of atoms and subatomic particles and so forth. Well, before we had those, the stars themselves were our insight into atomic physics. We didn't realize what made stars shine until the 1920s, when the concept of fusion finally dawned on scientists. And so by observing stars and learning their mass, and these stars that orbit one another, you can, in many cases, you can actually observe that over time and calculate their orbit, their period. And from that and other information about their color and so forth, you can start calculating mass, and you begin to get all kinds of insights into the stars. So there's one double that you can split naked eye if you have good vision. Rocky likes to talk about how it was an eye test for the Roman army or somebody at once upon a time. And that's what's the name of it?
Mizar and Alcor.
Yeah, Mizar and Alcor. Then the other kind of star that I wanted to bring to your attention are variable stars. And here again, you know, we talked about blue stars and red stars. Well, in a little bit, we'll get into this Hertzsprung-Russell spectrogram or chart and get a little deeper in this. But basically, smaller stars that are in the prime of their life, they're called main sequence stars. Main sequence stars are blue if they're really big. As they get smaller, they go white, then they go yellow, and then they go red. They're basically black bodies. If you take a piece of metal and heat it up, you start to heat it up, eventually it'll start to glow red. If you keep eating, it'll glow orange. You heat it some more and it'll start to glow yellow, more white, and you get it hot enough, it'll be blue. That's what's going on with the stars. It's just a function of their temperature. But the stars that are small enough to be red, you can't see them. They're too dim. You can see them with a telescope, but basically they're too dim. So the red stars that you see in the sky, I'm gotten ahead of myself, are late period giants. They're at the end of their lifespan, but a lot of those are variable. Now, there's all kinds of variable stars. There's baby stars that are variable, and they're aged, dying stars that are variable. There are all kinds of variable stars. But once again, they're a huge resource, have been, for scientists to understand the physics of atoms and subatomic particles and so forth and so on. And there are still these so-called red giants are still needed to be followed, and you can actually do this with some of them with your binoculars. Actually, you probably could do some of them naked eye, and they often cycle over a period of many hundred days. And this is a chart of one in Ursa Major, UMI, Ursa Major, Ursa Minor, I mean, T Ursa Minor, and all the blue dots are observers who, with a telescope or a pair of binoculars or whatever, have estimated the magnitude, and you get charts from the American Association of Variable Stars observers, and they will show you how to use that, and you can see how to use that, and then you can go out and plot one of these stars each. It doesn't have to be every night, once a week, once every other week, and turn your data in, and it becomes a blue dot, and it'll be recorded forever by the AAVSO. And then they take these findings, and you can see there's some scatter there, but it's amazing how accurate you can get by averaging out the observations of many different visual observers. I do this with a camera now, and a digital camera, and turn in my data, but you'd be surprised how close the visual observers, when you aggregate a bunch of them, are to what you get with precise. Okay with me. Yeah. So that's the only other thing I wanted to cover that we didn't get at the first version of the second night is the Astronomical League observing programs. And this is maybe a fourth of them. I couldn't get them all on the page. They got all kinds of plans. So the beauty of this is it gives you a disciplined project to work on. And if you got a project to work on, you're more likely to go out and do it than if you don't. You need to create a project. And they've got lots of projects here, and they've got them ranked by difficulty and the equipment required. So you can go in here and say beginner and unaided eye and binocular, and find like this at binocular double star project. So it's a bunch of double stars. I don't know how many are in there, and you go out and you observe them all, and turn in your record of your observation, and you get a pen and a placard, or whatever you call it. What do you got? Certificate, and so forth on down through here. You got all kinds of binocular programs, Messier programs, and variable star programs, and double star programs, and so forth, that you can do with binoculars. So with that, we are ready to start tonight's program. And we've talked already about the motions of the sky, but we're going to dig in a little deeper on it tonight. I won't hit this too hard because Rocky's already. Somebody needs to mute that. Let's just mute all the class for a moment. Rocky's already showed you with stellarium how the circumpolar region goes round and round during the night, but it also goes round and round during the seasons. It's just the different season that's up at a different time of night. If we take the Big Dipper as our clock here, early in the evening, it's up near the top in the spring. And people say, well, the spring is wet, and so it's dumping out water. up there. And then in the summer, it's in the early evening, it's over here to the west. And in the fall and early evening, it's in the south. And in the winter, it's over here to the east and rising. But of course, as the night goes on, as Rocky showed you, it spins around. So by in the winter, it will be where at around midnight, it'll be up here where it would be in the spring in the early evening and so forth. Oops, what am I doing? Yeah, okay. Let me get this down out of here. So, and then the rest of the sky rises in the east and sets in the west. In other words, it's not circumpolar, it's not always up. Uh, this illustrates how that works. So here's the Earth and here's the sun. So this is the daytime side of Earth over here on the right, and then back here on the back is the nighttime side of the Earth. So right now, I don't know what season this exactly is. I should have looked that up. What season they've got the Earth in? It's whenever Libra is a zodiacal. When is Libra the zodiacal constellation? Scorpio is October, isn't it? So this is maybe September. But at any rate, the real point is let's imagine you're over here on the far side of the Earth at right after sunset. So, and let's say this is September. So you can look, once the sun goes down, you can look over here and maybe you can see part of Sagittarius in the setting, in the process of setting in the west, whereas Aquarius would be right overhead at the zenith. We talked about the zenith, right, the meridian. And then in the far east, you might be able to look over here and see Taurus rising. Okay. Come midnight, when you're here, then you maybe see Capricorn setting, and Aries would be near the zenith. And you could look over here and maybe catch Leo. I'm going to skip that slide. We've done enough on it. It's gotten sensitive to me. So I mentioned earlier the now what? So I mentioned earlier the Hertzsprung-Russell diagram. And I don't know why it's dark. Anyway, the video cannot be played. I don't know what that's about. This shows the main sequence, really large hot stars up here that are
Bruce,
blue.
click on slide 84 down in the lower left-hand corner. Because you got the wrong slide up there right now.
I do. What's up there?
Your video. It's not playing, but it's up there.
I don't know. So you can't see this?
All I can see is slide 8 is the zodiac.
I see slide 83.
Yeah, slide 83.
Okay.
Click on slide. Can you go in the lower left-hand corner?
Let me do this. I'm going to stop share. And then I'm going to share again. It's just going to give me the same thing. I don't know why I'm seeing something different than you, and I'm sharing my screen. Participants can now see.
You got it right. You got the Hertzsprung-Russell on there now.
Yeah, I just don't know why it's dark. It still says this video cannot be played, and I need to get rid of that video somehow. But this chart, you can see it good enough, I hope, shows this is the main sequence. Big stars up here, hot and bright. Little stars down here, red and dim. And then this is where, when you see a red star in the sky, they're up here. These are red giants. And that's when they've are ending their life, the last phases of their stellar life. They end up here, and they're, even though they're red, they're bright because they're so large. They swell up. And when the sun goes through this phase, it'll take in Mercury, Venus, and probably even the Earth. And so that's the reason it's cooled down, is because it's so large, but that makes it bright enough. So I just wanted you to know that when you see a red giant, you're looking at stars up here. And when you see a blue star, you're looking at one, or a white star, a yellow star, you're looking at something that's on the main sequence. All right. Now we're going on with different kinds of motions and planets. This was a big puzzle to early astronomers. You know, we talked about how astronomy was the first science, and the obvious reason for it was it was so obviously informative to early peoples about seasons and so forth and so on. And so they thought there was a lot to be learned, and everything that they saw in the sky, except the moon and the planets, was seemed to be steady, stationary. In fact, it was even all the way up until Copernicus, and actually beyond was really Galileo. The thought was that the sky was unchanging, utterly unchanging, never changed a part of reality. But the planets fascinated them because they moved, and they thought that there was some significance to that. And the really curious thing about it was that they would go in retrograde. They seemed to go backwards. This was a big puzzle that Copernicus and others were interested in trying, and ultimately did solve. But so Rocky, explained to us how this happens using stellarium.
Well, as the, okay. I need to share my screen.
Yeah. Okay.
Okay.
Have at it.
Okay, what I've got is Mars selected. What happens is, as Mars is rotating around the sun and the Earth's rotating around the sun, the Earth is catching up to it, and then the Earth passes it. And when the Earth passes it, Mars starts looking like it's going in reverse, until the Earth gets on farther around, and there's not as much of an angle between them. But I'll show you how it works with stellarium. I've got Mars selected and several other things. And I'm going to speed up time. I think I'm in the right direction. So Mars is, oh, wait a second. Okay, there we go. I've got the time down in the lower right. You see how it reversed direction?
Uh-huh.
And made a loop on itself. And I first figured that out doing the Boy Scout merit badge again, because I had to do it as one of the requirements back in the 60s. But I don't think that's a requirement now. But any questions about that? See if I can go the other direction. This is about where it is right now, is up in this area right now. But it's already done its retrograde, and now it's going back the other way.
All right, I'm gonna take back over.
Stop share. Okay.
All right. So this chart up here just depicts that. You can see where the Mars is here, and because it's further out, it goes around the sun much slower. It takes it 2.5 years, about 2.5 years to go around. The Earth goes around every year. So we lap it in effect. And as we catch up with it, you can see how this seems to make it go backwards. So another little element of motion, we're covering motion here, is eclipse. And we're going to have a partial solar eclipse this year in October and a total solar eclipse next year in April. And a total, they say an eclipse is something to see and observe. A total solar eclipse is something to experience. If you haven't done it, you need to make a point to do it, because it is a moving thing to witness. It's just nothing like, but there's nothing, a partial eclipse does not resemble a total eclipse at all. And this just happens, of course, when the moon passes between the sun and the earth. And as I explained a few days ago, or in a couple of meetings back, they're actually subtend the same size in the same angular size in the sky. It's just a coincidence that that's the case, and that makes this possible. If that weren't the case, we could never have a total eclipse. But you should ask yourself, when you understand how this happens, well, wait a minute, the moon passes between the sun and the earth every month. I mean, that happens. That's what a new moon is. So how come we don't have an eclipse, a total solar eclipse every 28 days? Well, the reason is because the moon's orbit is tilted somewhat to its orbit around the earth. And so a lot of time, most of the time, it either passes a little above or a little below the straight line between the sun and the earth. Other things that move in the sky are comets. And as Rocky and I were reminded me to tell you all, if you get a chance to see a bright comet, take it. They are rare, and they're a lot of fun to watch. And with a pair of binoculars is a great way to look at a comet, if you've got a bright one, that is. And you want to look for the two different kinds of tails. You've got a dust tail that basically just follows behind the comet, and this is literally particles that are coming away from the comet as the solar wind causes the comet to vaporize. It leaves a dust trail behind, and then you have a gas trail that actually goes at a different angle, and that angle is defined by the solar wind. It's just carried by the solar wind. These are some shots of recent, comets in the last few decades. There's there's a lot of interesting history here. Halley's Comet, some of us in this group should have been around to see the last apparition. They call it apparitions. It's called Halley because Halley, the namesake for the comet, took Newton's treatise or work on his physics and used it to calculate when Halley's Comet would come again. It had been a comet had been recorded that the last two apparitions of Halley's had been recorded by various observers, and Halley, using Newton's work, applied that to those two observations and concluded that it was the same comet and that it was going to show up again on some date. I forget what the date was, and he calculated it to to the within a month of what was correct. And that first established, that was the first solid evidence that comets were not in the atmosphere. It was thought that comets were a function of the atmosphere. And one reason for that was because everybody thought that the firmament was beyond reach and never changing, and a comet obviously comes and goes, so it didn't fit the theory. So motions, was summarize some things about the sky. The sky moves overhead east to west 15 degrees an hour. Everything rises almost 1 degree, 4 minutes of time or right ascension earlier each day, or 2 hours earlier each month. So the objects you observe at 10 p.m. 1 month will be at the same altitude a month later at 8 p.m. The moon rises about 50 minutes later each day as it orbits, as its orbit is 28 days, 24 hours divided by 28. Something else that moves in the sky are meteors. And this is just literally random dust, but most meteors come from the dust tail I showed you about the comet. Well, that stays in an orbit. It tracks the comet's orbit where it was left behind. And if the Earth passes through that orbit, you get a meteor shower. They are very hard to predict exactly how how active they're going to be in a given year. People try, and but if you catch particularly any of them are fun, to tell you the truth. Everybody goes, if you're out in a star party or something and a meteor comes, people get excited about it. And if you have several of them happening in a few minutes, then it really gets to be fun. You can look up meteor showers on the web. Rocky, did you update this? Is this year's? Yeah. So
this is updated for this year.
Yeah, we may ought to pass this out. We ought to email this.
Yeah,
to
I'll
everybody.
I'll do it in the handout tonight when
Yeah.
when I get it
But
done.
what you need to do is you need to Google the meteor showers, and there are several websites that give you a rundown on each meteor shower. They're best again if you have no moon, so you need to find a dark site and a no moon night, and of course if the shower is peaking at a full moon or near full moon, it's probably not the best opportunity to view that particular shower that year. You can get all that information on the website. The space station is something else that moves. We touched about that on the Astrospherics website. Told you when the space station was going to be up. But you can go to Heavens Above and get the gory details, how bright it's going to be, what time it's going to be, how far above the horizon it's going to be, and everything you need to know to spot it. And it's amazingly easy. If you know when and where to look for it, it's amazingly easy to spot. You can do it without any instrumentation. And this is just a chart that from Heavens Above that depicts, and you can see the exact time when it's going to be in each of these constellations as it goes overhead. And it moves relatively fast. You can see here, this is 1856 and that's 1903. So it's not a lingering event.
That's 7 minutes.
All right, there you go, Rocky.
Okay. Let me share my screen.
Yep. Sorry. I want to fix that where you can do that automatically. There's a way to do that. Still learning how to use this thing.
Well,
Oh, you're good. You can share.
okay. Yeah, I don't have it set up. I want to talk a little bit about let me see if I can get it to. Okay, a couple the best meteor showers real quick. I wouldn't worry about the Lyrids and Aquarids unless you just really want to get into them. Perseids are fantastic, and this year they're going to have a 24-day-old moon, so the moon's going to be a small crescent coming up early in the morning. And what this means right here, the time is here's the date, August 12th and 13th. So most meteor showers you need to observe after midnight, but there's a few that you can observe. You can see some good results before midnight, and the Perseids are one of them. And so the night of August 12th and 13th, between about 10 o'clock to 5 o'clock in the morning, you can see a lot of Perseids, hopefully. And this year, without a moon in the sky, should be a good year. Another one is the Leonids, that every 33 years, they usually have a meteor storm. Unfortunately, in 2033, they're not supposed to be that powerful, but still good, I'm sure. I saw it back in 1999, and in about 3 hours, I saw about 400 and something meteors, 405, I think. And they were, most of them, a lot of them were fireballs, and they would light up the whole, you didn't have to see it. You knew it was there because it lit up everything. But those are spectacular, but that's like 2033. You can still catch a good one every now and then, and they're still worth watching. The Taurids are my favorite. You can see, it says maximum 0 zenith hourly rate. That's, you might see 5 an hour. The thing about, there's a couple of things about the Taurids. First of all, they're the slowest meteors, so they last longer, and there's a lot of fireballs. Also, I just heard Graham Hancock, I think it was, talking about they've gone back and they think that the meteor that caused the Younger Dryas, which was an ice age, and back in about 13,000 years ago, was a asteroid or something from the Taurid, a large meteor from the Taurid meteor shower. So they say that's one we've got to watch out for what do you call them, Bruce?
Yeah, existential threats.
Yeah, existential threat. The two best ones of the year are the Geminids and the Perseids. So those are the two that you'll get the best results of that. On the space station, this is tomorrow night. It's minus, you can see right here, I put the current data in here. 10th of March, it's minus 3.8, and it gets up to a height of 61 degrees. Another good night is 14th of March, and it's minus 3. It's really bright. I've actually with binoculars seen the, when it goes right overhead, seen the solar panels with binoculars. It can be that close. But anyway, that's just a little bit about that.
One thing real quick, while you're shifting gears, these meteor showers, that date in there is the peak of the shower, but some of the bigger showers like the Perseids, they actually, you can find Perseid meteors for a couple of weeks in advance of that peak, and a couple of weeks after. They just get more and more rapid. I mean, more and more frequent.
That's what this activity period is.
Yeah, there you go.
In July. Southern Delta Aquarids are a good shower, and you either have a bright moon during them or a bright moon during the Perseids. So one of them is going to be good every year. And we talked about this some, but winter is the brightest time of the year, and you can see all the first magnitude stars. And so I wanted to go through a little bit more about the winter hexagon. Hopefully you've gotten out to find Orion and maybe trace out the winter hexagon. So first there's Orion, and with binoculars, it's very easy to find, even in town usually. M42 is a very bright diffuse nebula in Orion, and Orion's sword. You got his belt, you got his sword, you got his shield. He's got a little bitty head and a club. So there's a lot of parts to Orion. and you can, and they're all bright enough to see pretty much, fourth magnitude. But there's another measure here. It's difficult. You need a good telescope for that one. Then there's Taurus, and Taurus has two very nice binocular objects, the Pleiades and the Hyades. The Hyades are Aldebaran is in the Hyades. It's not part of them. It's actually different, but the Hyades is I think the closest cluster to Earth, and open cluster to Earth. So it's real nice through binoculars. Got a lot, you can see the different colors and stars, and you can see some of the, if you think about it while you're looking at it through binoculars, you might be able to see some of those colors. Yeah, I know you can on Aldebaran. It shows up nice and orangish.
And those red stars are red giants. They're like I was telling you about. They're late life. They're late in their lifespan.
I think red giants, and well, Bruce knows more about it than I do, but the blue stars a lot of times don't last nearly as long as yellow stars and
that's right. They don't live very long. The large blue stars are short lived. They become big red giants pretty quick. And the Hyades cluster is a pretty young cluster. So what you're looking at is some really large stars that have already hitting into their late life.
Fortunately, our sun is supposed to last a long time.
Yeah. About halfway through.
Auriga at the upper right of the winter hexagon, it has a real nice pentagon shape, and the bright star Capella is like the fourth magnitude, fourth brightest. No, I think it's the sixth brightest star, and it's a yellow star. So I like looking at the yellows and the reds and the blues with binoculars, and you can see the colors better. These three are known as the kids. I don't remember. I can't ever remember what Auriga was. He's a charioteer or something like that. But he has three goats, and these are known as his goats. These three kids right here. One of these is one of the biggest stars, and it has it's a binary star. Bruce was talking about variable stars, and it had eclipses about once every 28 years, and it lasts about 3 months or something like that. The eclipse does, and we watched that back about 2000, I think. And it's got three nice open clusters. It's a real nice area to scan with binoculars, but it's got three distinct open clusters with binoculars that go right across the middle of it right here. So it's a nice one to look at with binoculars. These are the three open clusters here. Yeah, okay, back to the Orion Nebula. It's about 1,344 light years away in magnitude 4. So you can see it naked eye in a dark sky. Gemini is a neat constellation. It's got two bright stars. Castor just falls under first magnitude, and Pollux is first magnitude. And it's a nice constellation. I usually shape it as a square instead of like H.A. Rey shaped it with twins, like it actually is. When he did his book back in the late 40s or early 50s, he reimagined the constellations and tried to make them what they were supposed to be, like like in this case, it's twins. So he was able to do a pretty good job with this one and make the twins. There is one really nice open cluster here, real easy in binoculars, at the foot of Castor, the Castor twin, next to the foot. And this is a nice area in binoculars. It's got some more open clusters in that area. Then you have Canis Minor and Canis Major, and Canis Minor is very indistinct. It's only two stars that you can actually see. There's not any objects in it, but Procyon is actually one of the brighter stars. It's like the eighth or ninth brightest star, and it makes up that part of the winter hexagon. And then Canis Minor, and Bruce was talking about how Sirius has got like 60 something names, and every civilization has got has got legends about Sirius and like the Egyptians, when Sirius rises in the right before dawn, that's the start of their rainy season. But Adhara is like 1.55 magnitude. It's a really bright star too. So you got another one of the top 25, two of the top 25 stars there. And M41 is a bright open cluster. A lot of open clusters in this area of the sky, and diffuse nebula. In the springtime, you've got a lot of galaxies because we can see up through the galaxy, through the top of we're looking up. We're not looking through the Milky Way. We're not looking along the plate of our galaxy. We're looking up, so we don't have a lot of dust and stars to block the galaxy, so we can see the galaxies better.
Rocky, let me jump in here in just a second. And you were talking about the goats, the kids, I mean, and I had to go back and refresh my recollection. I'm looking at Wikipedia. You can look up all these constellations and get all the lowdown on how where these the mythology and how the constellations were formed or put together and over time and so forth and so on. So Capella is associated with the mythological she-goat Amalthea, who breastfed the infant Zeus. It forms an asterism with the stars Epsilon Auriga, Zeta Auriga, and Eta Auriga, the latter two of which are known as the kids. Though most often associated with Amalthea, Capella has sometimes been associated with Amalthea's owner, a nymph. The myth of the nymph says that the goat's hideous appearance, resembling a gorgon, was partially responsible for the Titans' defeat because Zeus skinned the goat and wore it as his aegis. I don't know what an aegis is. The asterism containing the goat and kids had been a separate constellation. However, Ptolemy merged the charioteer and the goats in the 2nd century Almagest. Before that, Capella was sometimes seen as its own constellation and so forth. So you can see how you can get wrapped up in this mythology, and a lot of people do, and it's a lot of fun.
Get confused too.
Yeah, and you'd also get confused.
And outside of the winter hexagon and between Gemini and Leo the Lion is it's a dim constellation, Cancer, which is important because it's in the zodiac. So the planets move through that, and the sun and the moon. But there's some really nice, a really nice object in it. There's actually more than one. There's another one down below it, another nice open cluster, I think. But Prespi, which means manger, is a very bright open cluster, really nice in binoculars. And it's out right now too, just to you can see how you can find it using Castor and Pollux and just go right over to it. Something that's neat is the two stars flanking it are the Borealis is northern, Australia is southern, and Ocellus is donkey. So you've got the northern donkey and the southern donkey flanking the manger. So that's kind of neat. Then below it is a neat binocular object. I mean, you can see it naked eye, but I like to do it in binoculars too. Is the head of Hydra is a nice little asterism down there. And one of the nicest parts of Hydra, I think. And we talked about the circumpolar constellations last week and the importance of learning the Big Dipper and how to find Polaris. And then Cassiopeia across from the Big Dipper. One of them is going to be up all the time. And sometimes they're both up at the same time. And Cepheus and Draco are other constellations to learn. And here are some key words to learn, to memorize the constellation names, and then go out and memorize the constellations. Cepheus, Perseus, I didn't mention, is one of the fall constellations, but it's almost circumpolar. This is it up here next to Cassiopeia. but it actually goes in the fall constellations, although it's pretty close to being circumpolar.
Hey, Rocky, what
Uh-huh.
do you do with the dates that are around the edge of that?
Okay,
What-
like right now, let me minimize this a little bit. It's what, March 15th? So
Yeah.
about 9 o'clock at night, if you hold it right at that point right there and just let it fall down, that's what the sky is going to look like.
So hold that to the bottom,
Huh?
hold that to the bottom,
No, hold that to the top.
to the
Just
top.
hold it and let the page fall down, let gravity take it, and where it falls is pretty close to where the stars will be at that time. So it's just a easy way to get your bearings in the northern sky.
Okay.
You remember a while ago that we looked at the seasons for the Big Dipper, and where was it in the spring? It was but almost straight overhead, right? It was 12
No, in the
o'clock
spring,
position.
in the spring is kind of where it is right now. It's coming up in the
Yeah, well,
east.
that's my point. You grab April 1 there.
Yeah, April 1, it starts getting overhead.
Yeah, it's nearly overhead.
Yeah.
It's about with the 1 o'clock position.
Okay. Okay, after the and I think we had a slide earlier, but I can show you here. After the winter constellations come, the spring constellations are coming up, and you can already see Leo very easily in the east. It's up right after dark, and it's a distinctive constellation with a sickle, or it looks like a sickle in the front and a triangle in the back. So it makes a pretty good shape for a line. And Regulus is one of the brighter first magnitude stars, and it's very close to the ecliptic. And so planets sometimes go pretty close to it. The moon occults it every once in a while, as it does Spica, which these are the two closest bright stars to the ecliptic. But you can to start finding it as you can take the Big Dipper and take the tail of the Big Dipper and make an arc to Arcturus. So that's kind of a memory aid to help you remember the name of that star. And Arcturus is like the fourth brightest star. It's an orangish star, and it's right now you can see it about 10 o'clock or 10:30 at night. If you go out, you can make your arc to Arcturus, and Arcturus will be coming up in the northeast. When it gets a little bit higher, you can easily make out the Arcturus doesn't look like the bear driver that he is. He looks more like a kite, and you can see he's shaped like a kite. And it's fun to trace out Arcturus and find the kite. This is some nice pairs of stars, and I think one of the new telescopes a nice double. Right next to it is a neat little constellation, half a circle, the northern crown, Corona Borealis. But after you make the arc to Arcturus, you can speed on to Spica, and that's another memory aid to help you remember the name of that star. And I like to look at Virgo, which is Spica is in, as two things. It's got a diamond here, which kind of mimics the shape of the spring diamond, what we call the spring diamond, but this is Virgo's diamond right here. So she has a diamond too, and she also but I really like the cup. I see the cup more than I do the diamond, but the kind of like the wedding cup or something like that. But and then to finish out the spring diamond, you've got the tail of Leo, which is Denebola. Deneb's another star. It means the tail. It's the tail of Cygnus the Swan, but Deneb is Arabian for tail, I think. And then the fourth star in it is Corcoroli, which is a nice double star. But Corcoroli means the heart of Charles, and I, there's different legends on who named it, but one of them is Sir Isaac Newton named it after Charles II, I think, that was killed, was beheaded in about 1650. And anyway, they named it for the heart of Charles. So they renamed that star. It's actually in the constellation Canis Venatici, which is our Boötes hunting hounds, pair of hunting hounds. Used to be two constellations there. Used to be the Northern Hound and the Southern Hound. But there's some nice objects in these in there. You really need a telescope for most of them. You can pick them up in binoculars on a good night, some of them, but these are galaxies. So this is in the galaxies region. The last constellation here is Coma Berenices, which is, so you got, and it's named after a real Egyptian princess. Queen Berenica was the queen of it's not Libya. It's Benghazi now, but it was it's in Libya, that area of Libya. She was the queen of Libya, and anyway, she killed her husband because her husband wasn't good to her people, and then she married Ptolemy IV and moved to Alexandria, Egypt. And she was pretty. There's actual coins with her likeness on the coins, with her on the coins, from about 250 BC. And anyway, she had long hair, and her husband Ptolemy IV had to go to war, and so she promised the gods if they brought him back safely, that she would give her hair to him. And so when he got back safely, she cut her hair off and put it on the altar. And the next morning, her hair was gone. And so they were all up in arms because they felt like somebody had stolen her hair. And Conan, who was an astronomer and a scientist, I think that's where the name Cone came from, because he was into that kind of science of hydraulics and stuff like that. But anyway, as an astronomer, he said, "Oh no, look, they took your hair and put it up in the sky," and he showed him this cluster right here, which is Coma Berenices. So that's where the name that came from. So you got two things right here that are named for people, actually named for real people: Charles II and Queen Berenica of Egypt.
Now, Rocky, M3 here, between Arcturus and Corona Coralis, you could probably see that through binoculars, couldn't you?
Yeah, that's easy for the binoculars, easy to find halfway between those two stars. And that's a globular cluster. Something that we really hadn't seen much of. I don't think we've had any yet. They're mostly in the summertime when you're looking toward the core of our galaxy. You see a lot of globular clusters. But there's a few in the spring. M53, M3 is brighter than M53. All these galaxies in here, some of them you can see through binoculars, most of them take a telescope, and it's a real chore to find all the galaxies that are in this area. There's actually another chart in this book that shows this area right here, where there's about 10 or 11 Messier objects to find in that and in the Virgo cluster. And if you get the book Learning the Constellations, beside the spring diamond, it has a description of a lot of it, how to find the spring diamond, a little bit about Boötes and the objects that you might want to look at in it, primarily through astronomers. It tells you if you need a telescope, and it goes through maybe a little bit about the mythology, but mostly about the objects that are in it. and that's in the book. How much time we got, Bruce?
10 minutes.
Oh, we're good. Okay, Boötes, and I talked about it a little bit, is a herdsman or as a plowman driving the oxen, which they thought was the Big Dipper, driving the Big Dipper around the sky. Looks like a kite adjacent to Coma Berenices, and I think I told y'all all that. 37 light years away, and there's a M3, which Bruce brought up, and that's about the only. That's actually in Canis Venatici, I think. There aren't any Messier objects in our Boötes. And then here at Virgo, in these zodiac constellation, Spica is a blue-white first magnitude star, about 250 light years away. The Virgo cluster has a lot of galaxies. And back about 1820, I can't remember his name now, put out a set of cards with constellations on them that were very pretty, and you'll see a lot of the when they want to dress up the constellation and show what it's supposed to be, they'll show the depictions from these cards. And Leo, the lion, is an ancient constellation resembling a lion. Regulus is the king star, regal, meaning regal. A blue-white star, magnitude 1.4, about 78 light years away. And back around 6 BC, we talked about retrograde motion. Well, Jupiter, you can see my thing here, Jupiter came by Regulus, came back, and came by Regulus 3 times. And when it did that, the wise men who were astrologers thought that meant that prophecies from Daniel had come true, and that there was and they think that may have been one of the signs that they had for the for Christ. And 2 other signs that happened at that time, I think I may have mentioned them because we had a real nice conjunction of Jupiter and Venus a few weeks ago. Was they had 2 conjunctions of Jupiter and Venus where they were so close that they couldn't see them, and that's about 1 or 2 BC. So they feel like those 3 things may have been things that contributed to astrology back then, which was a bigger science back then than it is now. The 2 hunting dogs I talked about are named Asterion and Chara. And Chara is the name of this second star in Corcaroli. Corcaroli is a real nice double through a telescope. M3 is a nice binocular double. We talked about Coma Berenices star cluster. And there's another chart because I had a chart in there for mainly just the spring diamond, but there's all these other constellations that are around it that I added to another page that are, once you know the spring diamond, you can start being able to locate. Corvus is real easy. Corvus is bright. It's a nice little constellation. Crater's pretty dim. Hydra's is kind of fun to trace out. Sextans is not too easy. Libra, another zodiac constellation, is easy with just 2 stars. And Bruce, let's save summer diamond until next week and the fall
Okay.
square.
All right. Sounds good to me. So, question time. Is anybody still here? Yeah.
There's still 12 down there, so that's good.
Yeah. Turn your mute off and ask questions. If you got them. If not, we're going to give you 5 minutes back.
Well, you did a good job, Rocky and Bruce.
Thanks, Mike. All right. Well, we'll see y'all Thursday.
Yeah, thanks for y'all's time doing this.
All right.
Thank y'all very much.
Thank
Bye-bye.
you.
Thank you.
Bye-bye.
Good night.